Hey guys, it's the week 6 review, and we're going to start with looking at the server side here for the market history backend. Oh, my SSH connection died. Go ahead and restart that. Alright, so before we had a bit of an issue with CPU loading. It's because there were some MongoDB indexes that were incorrect, which was causing a full parse of all documents in the database. And we store every epoch per trade pair as a document. So there's like 800K documents in this database. So indexing, very important. Also, SSH died again. Not sure what's going on there. But it still works. Okay. Anyways, we'll move on to refactoring the network. So I changed the model code a little bit. I had to normalize the prices of Bitcoin, or I guess alternate coins, because you've got some coins that trade at like $2 a coin, or 2 Bitcoins per coin, whatever, and some that trade at like 0.002. So I had to normalize this. So I wound up just using the high price and whatever these variables are, ask, bid, open, close, high, low, and then integrating that into the network. So I'll go ahead and run the network. So right now we're getting trade pair data from this range to this range from the MongoDB server. We returned 150 epochs, and there's one solution set, which is basically the final solution that we're looking for. So now we're taking the data and we're changing it from what's stored in the MongoDB to what we can feed into TensorFlow. So we have imported all these epochs, and there's some missing keys, so we patch those. It's far less than what it was before. Before it was really bad. The CPU usage was really terrible, and there were like hundreds of documents waiting to be queried. It was bad. So luckily, fixed the CPU loading issue. Good to go. Alright, so this is done. There is kind of a thread hang at the end, so just Control-C it. It's a Python timer. I have to go fix that later. It's not critical. So now we're done running the training set, and we'll launch TensorBoard to view the data. Alright, that's running. Copy the link. Oh, wanted to stop here for a second and show what the actual data set's looking like. So there's V2, V3, V4. It's kind of been like a evolutionary kind of system. It changes every time I push code. So V2 and V3 are pretty much garbage. So I will eventually delete those. V4 has a missing gap from a couple hours today. We had a power outage due to construction down the road. So I had to shut down all the systems. But we're up to 11 gigabytes, which is nice. It's a very large data set, but there's missing holes and pieces incomplete, and you can't really do machine learning if you're missing data. So I kind of just want to like can all these and start over, but I may keep V4 and just let it run, and maybe reset the epoch to like today or something, so that we miss that the gap from data. This is why having things on a cloud where it's like multiple backup, multiple redundancy, you don't miss data, because in these kind of machine learning environments, like your data integrity is really critical. You can't have missing stuff or your network doesn't work right. All right, so back to TensorBoard. So the new network, divides, I guess this is the normalization function over here, this division function, and then we multiply everything back in. It looks kind of the same. It's not as complex as I would like yet, but I'm still learning the ins and outs of how to develop multiple layers inside a machine learning environment. But the one thing I can say is that our cost function, so cost is basically how is the network working? How well does it perform? We started here at about 0.053. I'm sorry, 0.53. And then we learned really quickly. There were some regressions, and then it learned and regressed and learned and regressed. That's because the network doesn't have enough variables to capture what we're trying to, model. And that's where expanding the network in the future will come in, which I guess is next week. But our final endpoint was 0.17, and we started at a 0.53. So if the network is performing this much better and can give an answer that is, a lower cost, then we could model that and it would, return into like, buy this coin or buy that coin or, transfer these into that. So if we look at all the variables here, we've got ask price, bid price, close price, the cost. Cost function is kind of the most important one. All these other variables go into that cost function. So that's really the one you want to focus on. That's like the end result. Yeah, so next week will be more network development and starting integration. Thanks, bye.